Okay, so I think we'll get started. So hi everyone, I'm Nicole from Primary Engineer and welcome to our online interview today. And today we've got Simon Ponting, who is an engineer from Weir Minerals, the Weir Group. Before we get started, I'll quickly run through what's going to happen during this session. So the first part will be Simon's presentation, and that will then be followed by a Q&A section. So please feel free to type in any of your questions at any point during the session. And then when we get to roughly 1:15, we'll get straight into it and answer and ask as many as possible. So what is the If You're an Engineer, What Would You Do competition? The main aim is to inspire young people, ages 3 to 19, to look at the world around them and start designing some solutions to problems. These can be something as simple as making toast or getting dressed to a worldwide problem like pollution or plastic waste. We provide these opportunities to meet and interview professionals online, just like we're doing today with Simon, and to hopefully inspire you to think of some ideas and start designing some solutions to problems. So without further ado, I'm going to hand over to Simon. I'm going to stop sharing my screen, so you should hopefully be able to start sharing yours.
Yeah, lovely. The right one. Yeah. Okay. Hello, everyone. Yeah, my name's, as I said, Simon. I'm going to talk to you a little bit about engineering, what engineering is, how I got into engineering as a career, and then a bit more about what I do on a daily basis. So first of all, what is an engineer? An engineer is someone who uses their scientific understanding of the natural world and uses it to invent, design, and build things, solve problems, and achieve practical goals. Now, that's my boss's definition. The real definition really is that an engineer is someone who solves problems. Any problem you think of, however small, is generally engineering. So one thing engineers don't do is just solve a problem. It always continues rolling. You can always make a solution better. So if, for example, your problem was, how can I get to my destination quickly? The solution would be a car. Now, 50 years ago, this car would have been a great solution. But engineers are always looking to improve things and make things better. So nowadays, we have much faster, safer, more efficient cars than we did, say, 50 years ago. Same goes for things like flying. So if you wanted to go to another country and a pilot turned up and said, do you mind getting on this plane? I wouldn't want to go. I don't know about you. But that's because engineers have developed this and made planes that are much safer, much more efficient than they ever used to be. Same thing with phone calls. If you wanted to speak to someone 100 years ago, you'd have to write a letter or use one of these very old telephones. Now, everyone has a smartphone. You can talk to anyone in the world within seconds using a call, a text, whatever. That's because engineers have just developed the problem and helped solve it using continual improvements rather than just reinventing everything. So not everything has to be done from scratch. You can always use things that exist. So another thing is there's hundreds of different types of engineering. Here are just a few. So first one is mechanical engineering. This is what I do. Mechanical engineers look at physical objects, how they interact with things around them. So for example, this car, the aerodynamics of it is mechanical engineering, as well as the engine inside it. Chemical engineers is another type of engineering. Now these would focus mainly around chemicals. So using oil and looking at what type of petrol is best for cars, whether it can be more efficient, whether it's petrol or diesel, or how it can be done. They also look a lot at plastics as well. So the plastic handle for this petrol pump will have been developed by a chemical engineer to make sure the material is correct. Another type is structural or civil engineers. These look at big structures such as buildings or bridges. And finally, then there's software and electrical engineers. These look at computers, electrical circuits, like the inside of every device you can think of, a phone or a laptop. All of them have got electrical circuits inside. And they'll have been designed by an electrical or software engineer. All engineers are basically, all different types are just experts in certain kinds of problems. And that's the only difference. They're all engineers. They all just solve problems. They're just more specific on what areas those problems are solved in. So who am I? I'm Simon. I'm 27 years old, and I'm a design engineer for Weir Minerals. My job is to design process equipment for the mining industry. I'll explain that a bit later on. But how did I become an engineer? So when I was younger, about your age, I guess, I used to love playing with toys like Connects and Lego, building things, taking them apart, smashing them up, putting them back together, making them look cool, making them work properly. All that sort of stuff was what I enjoyed doing. Used to make toy tanks with my granddad as well, out of wood, using saws and chisels and things. I used to love doing all that sort of stuff. Then at school, my favourite subjects were maths and science and PE, but yeah, maths and science for this. And those basically give me a grounding in engineering. So I used to find things like airplanes and big pieces of machinery fascinating as well. So when I was 16, just about to come to the end of secondary school, my dad suggested that I did a week's work experience in an engineering office. So here they designed parts for fighter jets. I thought this was pretty cool. So I was shown how they design parts on a computer, and then I went down to the shop floor and built the things that I'd just seen on a computer physically. I thought, how cool would this be as a job? So I decided to go to university in 2012 to study how to become an engineer. So whilst I was at the University of Huddersfield, I learned a lot about different things like materials, aerodynamics, and computer-aided design. I spent a year and a half on a placement working as a trainee engineer for an oil and gas company. They make equipment that sits on the bottom of the sea, like this. Making things that sit on the bottom of the ocean is not easy. And I learned loads here about what engineering companies work like and realized how big projects can be when a group of engineers get together and work properly. After that, I graduated with a master's degree in mechanical engineering and got my job at Weir Minerals, where I've been for 3.5 years now. So one of my favorite projects that I did, well, my favorite project that I did at university was to design and build a drone with a group of friends. This was a group project where we started with nothing. We had to design all the parts, put it all together, and then we entered an IMechE competition alongside 14 other teams. Our drones had to take off, fly to a checkpoint, drop a care package and fly back and land automatically, all by themselves without us touching it. So for this project, we needed to use mechanical engineering to build the outside of the drone. And we used a lot of electrical engineering to build the brains and the actual flying parts of the drone that made it work properly. I loved doing this project. It was a lot of fun, spending all day just trying to get our drone to work exactly how we wanted it to. To top it all off, at the end, we did win a safety award at the competition, which was good as well. So what is my job now? So as I said, I design process equipment for mines, but what does this actually mean? So if you're mining gold, for example, you don't just walk along the street and find some gold on the floor. Gold is buried underground inside rock. So this is an example of a piece of rock that you dig up in a mine. You've got pieces of valuable ore in it. So there's your gold inside. And then you've got rock around it, which is just gravel. So you need a way of separating your rock from your gold. That's basically what our company does. So this is a mine site, which has got different pieces of equipment which help with this separation. Here's a big dump truck, which is bigger than any lorry you'll see on the roads, just for a bit of scale to show how big these sites can be. So the first step in breaking down your rock is to use a big crusher. This just smashes everything apart, and you get a mix of your product and the rock that you don't want. And that is this little piece here, which is huge in reality, but it looks small on this screen. So once it's all squashed together, you have rock and metal, but it's intertwined. So it's loose, but it's still together. So you need a way of separating those out. That's where our equipment comes in and what my team does. So we work on a thing called a Cyclone. Now that is this piece of equipment up here. So a Cyclone separates rock and metal. So what you do is you put it in water and then you pump it into the Cyclone. It spins around inside the Cyclone. And your heavy stuff comes out the bottom and your light stuff comes out the top. This works on weight, not on size of materials. If you take a bowling ball and a football, they're about the same size, but they weigh very different amounts. This is the same. You could have a piece of gold that is the same size as a piece of rock, but it's much lighter. So what this does is all the heavy rock comes out the bottom and all the light gold or metal will come out the top. So what we then do is we get a group of these cyclones, put them in a circle and call it a cyclone cluster. Now this is the main thing that I work on day to day. So, oh, sorry, I'll just do this again. So that picture is exactly what I see on my computer screen when I'm working on it. So I work basically on a computer most of the day and designing things like this, but you can't really see how big that is on a computer screen. So here are some actual pictures. So this is me stood next to one that I designed. I'm 6'1" for reference. This is about the same height as well. So you can see that these are massive pieces of equipment that take a lot of building and quite difficult to put together. Some of them can be a bit smaller. So this one is about as tall as me, but it's that's when it's nice and new and clean. And then when they go into a mine site and they're used for a couple of days, they don't look quite as clean and nice. But that's one that's been used for a couple of weeks. So, like I said, I've got it on my screen, and then we have to turn it into something real life. So how do we do that? There's the one that I've been working on. The main way we do this is using technical drawings. So this is a big key part of my job, is to turn what I've designed so that it can actually be manufactured. So this is basically an instruction manual that shows people how to put every little part together, detailing every little thing that needs to be done. It's basically like a technical way of putting Lego together. The little booklet you'd get is basically what we end up making, but for these pieces of equipment. We do a drawing similar to this. You know, we've got all the dimensions on it, and then there's a list of notes and how they should be built, so that somebody else can just pick it up and go, right, this is what we need to do. Like I said, that's a key part of the job, is turning in what you've designed so that other people can understand it. So at work, I also get to do some other pretty cool stuff, like using 3D printers to print parts out, to test them, and using the computer to simulate what is actually going to happen in real life. So this is an example of a valve body, which is just another part that we do. We put it on a computer, and then we tested it, how it would be tested in real life, but on a computer. So we didn't have to make anything. We can just use our fancy computers to work out where it might break and then improve it before we have to make it. So then we used a 3D printer to print it off and build it up, make a part strong enough after we'd analyzed it. And then we sent that part to a team in India who did the testing for us. And they basically did exactly what we did on the computer, but in real life, to show that it would work properly. So everyone does engineering all the time to solve problems. I'm lucky it's my job because I became an engineer, and I get to design and build things that I never knew could exist, using complicated computers that I never thought I'd be able to understand. But if you were an engineer, what would you do? Thank you for listening, and if anyone has any questions.
Okay, thank you, Simon. Those clusters look absolutely huge.
They are. It's scary how big they are, some of them.
So you're 6'1", so that was probably more than 12 foot?
Yeah, but some of them can be about 5-6 meters tall.
Wow.
In diameter, so yeah. Need a big old factory to build them in.
Definitely, yeah. So I'll just remind everyone that there's a Q&A facility at the bottom of the screen. So if you've got any questions whatsoever, then you can type it in there. I've got the Q&A open. So kind of part of that cluster, the Cyclone cluster, what's the most difficult part of making that?
It's making sure that it doesn't wear out. So you've got, if you rocks and metal wear things out pretty quickly. Mm-hmm. If you scrape a rock across a car, it scratches it. So we make the tanks out of the same metal your car's made out of. We don't want it to be scratched. So we have to control that. So we use rubber we rubber line everything, which is quite a difficult process to do. And we sort of have to control the speed that everything goes in at. So a lot of the hard stuff is done before it gets to our team, because they control how quickly it comes in. If it comes in faster, it wears out quicker. So we have to adjust what we do based on that, really.
So we've already got some questions coming in. Juliet
Brilliant.
has asked, how long did it take you to make the drone? So I guess in that challenge that you took part in.
It was a year-long project. Yeah, so we were doing other things as well. So we were also in lectures and things. But we probably built it in about 8 months, and then spent sort of 2-3 months sort of testing it and refining it, making it better than what it was, and not crashing it into trees, things like that.
And I saw on top of that as well, because I'm guessing you had to work as a team. So do you think that is kind of a personal quality that you need to become like a successful engineer?
It helps being a good team player. I mean, I think it helps in any career, being a good team player, really. You can get away with it in engineering, because you can be, there are there are some nerds in it, I'll be honest. There are nerds. So there are some people who are very, very clever, who you value their opinion even if they're not the easiest person to get on with, which was the case with that. But if it depends what you want to do. If you want to be an engineering manager, which would be my boss, you need to be good with people, because you need to be able to tell people how to do things. My boss, all these cluster things, my boss has taught me how to do it all, really. If he was a difficult person to work with, I wouldn't have learned it and as quickly as I have, and enjoyed it as much as I have. So yeah, it definitely helps.
Yeah, definitely. And again, another question. So this is from Anonymous. I'm not too sure who sent it in. How many different things have you designed in your career as an engineer?
I've probably done about 30 of these cyclone clusters, if we put it that way. There's obviously loads of little bits inside them, so I wouldn't want to count all of that, but yeah, probably about 30 different ones of these clusters.
So quite a lot.
Yeah, they come. I mean, they probably take about a month each to do. If everything goes right, obviously problems crop up. If something gets made wrong, or I've not done it properly, it can take a bit longer. But yeah, generally it's about a month.
And I suppose, how many people would roughly be working on each of those cyclones?
So our team at the moment has got 6 people in. So my boss, who does all the checking, so once we've designed it, he's got 30 years experience with these, so he can look at it straight away and go, no, that's not going to work. So everything goes through him, really. And then there's 3 of us that do the work. And then we have some contractors who do the technical drawings for us if we're busy. So they're not as clued up on the actual assembling of them, but they're very good on the system to build the technical drawings. So we can sometimes give them that work to do.
Okay, Juliet again has asked, how much gold do you find in a day?
It depends. It massively depends. I don't know is the honest answer. It can be quite a lot, because you've got big trucks doing a lot of things, and the people mining the gold want it to be done. They want to make as much money as they can, so they want to make as much as quickly as they can. So we can design something to say it will push through, say, 3,000 litres a second. Some of them can do. So that is, if you think of an office water cooler, it's about 8 of those every second can go through a cyclone. And if you've got 8 cyclones, that there can be a lot of water and processed rock and stuff going through that, but not all of it's gold. So yeah, I hope that helps.
So a lot. A lot of
Yeah,
code.
it can be a lot. Yeah,
Yeah.
and it depends on the site. So some sites can have one of these cyclone clusters. Some of them can have four of the big ones because they're in the middle of Russia and there's no one out there, so they can just use as much space as they want and dig into what they want. Whereas here in England, you can't. There's not as much space, so you can't do that as much, and there's not much gold. But yeah.
Yeah. Okay, so Juliet again, she's on fire. What is the best part of your job?
Best part of my job is when you see something finished, when you get to stand next to it after working on it for 2 months, and then it's been built for another 2 months. Problems come up, and then you fixed it, and then when it gets sent out to the customer, that's the best moment, definitely. But I enjoy the designing of it best. So when you're putting it together, making sure everything works on the screen, that's the most fun part. But then the best part is when it's finished.
And I suppose on top of that, what is the largest or I suppose most interesting project that you've worked on?
We've had probably the biggest ones. The biggest cluster I did was the most interesting because, like I said, there's so much stuff going through them. When they're there, they're so heavy. So you've got to be whatever they're stood on. They can, because these are sites, they can be stood at the top of a platform that's just like some scaffolding. You've got to make sure that it doesn't break under that extreme weight. So you analyze it in the computer and then you redesign it, and then making sure everything's strong enough is definitely the most interesting part.
And so I suppose, I don't know if you'll know off the top of your head, but how heavy are they?
So this one here that I've got the picture of, I think that was 60 tons. So 60 cars effectively in weight. That's empty. So we also have to think about it when it's full. So if there's a problem and some of the outlets get blocked, it fills up, basically just becomes a sink and fills up with rock and water and stuff. We then have to work out how much that can weigh. I think for that one it doubled, so it turned into 120 tons. So that's a lot.
Definitely a lot.
Zeros in kilograms. Yeah. So they can get pretty heavy.
Yeah,
Some of them
definitely.
that's an extreme case. Some of them can be, I say lighter, they're still 30, 20 tons, so it's still heavy. You couldn't get even close to lifting it, but it does vary.
Yeah. Okay. So a new one, Elliot. How hard is your job? And also on top of the previous question, how did you make the cyclone so large and why?
So that the cyclones aren't controlled by us. We have a design team in Australia who actually design the cyclones themselves. We just sort of put them together. The reason they're so big is so that they can get more stuff through them, really. And it also depends on what size and what metal you're dealing with. So, I might be doing too technical here, but you have it's called a cut point. So you in the cyclone. So it's the size of material that it accepts or doesn't accept. And the bigger the cyclone, the bigger that is. So if you're dealing with something like sand, you need that really small, so you'd use a smaller cyclone. So if you're dealing with something bigger, so copper particles are quite big, if you're dealing with them, you'd use a bigger cyclone effectively. So it just varies on what the mine site wants. And what was the other? That was the second part. What was the first part? Sorry.
So the first part was, so how hard is your job?
How hard is it? It depends. So it depends what day it is. Really, I don't find it too hard because I enjoy it. I think that's key. So any job really is just enjoying what you do. I think you get so much training when you're young that what to you guys would look really hard. If you've been what I've been through, anyone could do it. It's just you just get taught how things work, how to do it. So there are days and there are challenges, yeah, but I don't find it difficult. It doesn't stress me out at night. I can switch off pretty easily from it. Yeah.
So what kind of steps did you take to become an engineer? What kind of, did you do DT at high school?
I did, yeah. I focused mainly on the theoretical side, I suppose. Our school wasn't the best DT school, but it was a good science school. So I did my GCSEs. I did IT. I did a full IT course, and then triple science PE as well because I enjoyed that at the time. And something else. But then I did A levels. I did maths, chemistry, physics, and PE at AS, and then did maths, chemistry, physics at A level. So I mean, it sounds nerdy. You don't have to do that. That was my route because that was what I was better at. My grades were better in those subjects, so I did it. If you hate chemistry, you don't have to do chemistry. You'll find that when you get to later in secondary school, you do modules called like mechanics in your maths, and that was what really sold me onto it because I really enjoyed that. It was, they give you practical questions about how fast the car's going at this speed and this sort of thing. And I enjoyed that, and that's what really led me on to wanting to do more of those subjects. But they're not key. You can do something fun as well.
And are there any apprenticeships that people could take part in instead at potentially the Weir group, and that could get them into?
Yeah, massively. So my route is one route. I did A levels and university. That's one route. We also have guys who go 16, go to college. I think that's changed now, but yeah, do it or go to college and do a year at college doing an engineering thing, and then have a apprenticeship where you're working full time and then doing one day in college, basically learning what I learned at uni, but one day a week. So that takes a little bit longer. So I did, but you're getting hands-on experience. So I haven't got a lot of hands-on experience compared to people who've done an apprenticeship. It just depends what you like doing, which is the best route for you. And sort of time-wise, I did a master's degree. So you can do a degree in 3 years. I did the placement year and a master's, which made it 5 years to become qualified. And an apprenticeship would take about 7, but you're working as well. So that was the other thing. I wasn't being paid whilst I was at uni, whereas the guys who are doing an apprenticeship, they're being paid to work whilst they're learning. So it's different. There's loads of different ways to do it. Yeah.
I suppose it just depends on your learning style. So just do the research and find what works for you. Juliet again has asked, are all cyclones yellow and blue?
Ours are, yeah. They have to be for marketing purposes. So it's more so that they stand out. So if you see a mine driving past it on the motorway or something like that, or if someone's given a tour and you see a big yellow cyclone, you go, oh, what's that? It's bright and yellow. That's basically the reason.
Go research who it is.
Yeah.
Okay, so we're kind of running out of time. We only have roughly a minute or two left.
Okay.
Do you do any engineering projects in your spare time for fun?
Yes, I suppose I do. It's more, there's a bit of DIY. I'd sort of class that as engineering sometimes. And fixing things. So fixing my car, something breaks around the house, fixing that. But yeah, when I've got my own house, I'm going to do a lot more. That's for sure. At the moment, we live in a flat, so it's not as easy to use a garage and do things. But when I was younger, I used to, do a lot of work on my bike, that sort of thing.
Okay, well, I think we'll end it there. So
okay, lovely.
Thank you, Simon, for taking time out of your day to join us today. And thank you everyone that's been handing the questions in. We've got so many, and thank you for watching us today. If you want to have any more inspiration, then you can go to the leadersaward.com website. And yeah, I think that's everything. So thank you, Simon.
Okay, brilliant. Thank you, everyone. There's some really good questions there.
Thank you.
Thank you. Bye.